This is going to be a video on the stadium seating program, which is really a fairly simple program. We're going to do a few extra things in here. And there's actually an issue that kind of makes no sense. So I'll explain that as we go by. So we have 3 seating categories. One is $12, one is $15 for Class A, and Class C is $9. So we want to write a program that asks how many tickets for each class of seats were sold, then displays the amount of income generated for each ticket, format the dollar amount, and fix point notation with 2 decimal places. So basically, because we're using integers times integers, we're always going to get 0.00. But we're going to write the program that way to start off with. So what I want to do is get you to understand anytime that you have a literal number that is not going to change, such as the 15 or 12 and the 9, you always want to use a constant. So you'll understand why in a minute. So let's start, and we're going to declare constant integers. And we're going to do it in the same way that we would do it in any other one. Only we're putting the constant, C-O-N-S-T, in front. And constants are all in uppercase. So I'm going to put in Class A price. And that happens to be 15. And then I'm just going to copy this. And we need to make sure this is B. And this is C. And then we want 12 and 9. So the difference between the variables is in the constant, it's all uppercase, but you need to put an underscore between each word to separate it, because if they were all uppercase, there's no way that you're going to see the difference. If you had Class A price, it would be all running together. So now what we need is we need 3 more numbers, and those are going to be the seats. So we're going to do integer again. And these are going to be regular variables. So we'll I just call it num. We can call it seats Class A. So let's just do Class A equals 0. And let me hit the enter key here. And this will be B. And this will be C. Now, yes, I could have done integer Class A, B, and C at one line, but this looks so much neater, and this allows me to put a comment here. So we're just going to do cost of seats for Class A, etc. And this would be number of tickets sold for Class A. And an acceptable comment would be cost of the seats for Class A, B, and C, because you don't really have to put in cost of seat for Class B. That's kind of obvious. And same thing with here. You could if you wanted to. So, and then what we need here is we need the actual, we're going to change it later on to something different. So what we want to do is calculate the cost of those seats. So to avoid a change later on, I'm going to declare these as a float or a double. Doesn't matter. Let's just do double, because they want to stay away from float as much as possible. And what I'm going to do is I'm going to type revenue Class A, but this time I'm going to type in 0.0, because that specifies that it is a floating point. And we'll do one more. And we'll make this B and C. and we'll just put revenue or cost sales for Class A, whatever you want. And then, of course, we have the same thing in here. So now what we need to do is we need to tell the user what we're going to actually do. So the first thing is, let's get the seats for Class A. So we'll do how many seats for Class A, question mark and a space, no end line. And then we're going to do C in, and it'll just be num Class A. We could have done seats Class A, num seats Class A. So, just use your own judgment. So let's do num Class A. And then we'll just copy this and change what we need to change. So we need to make this B. Now, if you copy and paste, make sure that you change this. Otherwise, you'll get wrong data. So now we have how many seats are in here. So just to make things a little bit simple right now, we'll do one at a time, but let's check to see if our seats are correct by totaling up the number of seats in here. So what we're going to do here is because seats has always got to be an integer, let's put in here total sold, or whatever variable that you want. So let's go, and it's very simple to figure out that. Let's go total sold, and this will determine if our variables are input right. So basically, it's just num A plus num B plus num C. And then we'll do C out, total seats sold is total sold. So let's go and we'll do something simple and we'll see if everything works out just fine. So how many seats? So we'll do 10, 15, and 20. So that should be 25, should be 45. So if we got it right, we'll find out. Total seats sold is 45. So that's fine. So now what we need to do is we need to calculate the total revenue for each class. So it's going to be the same thing. We need a total revenue in here. So we have a double already. And let's just put in total revenue. Hopefully I spelled that right. If not, oh well. So how do we calculate how much the revenue for Class A is? Well, it's simply the number of seats sold times the price for seat A. So let's go and start doing that. And we're going to do revenue Class A equals num Class A times Class A price. And then we'll do the same thing for B and C. And again, you need to make sure that you don't forget to change these in here. Sometimes it's actually easier to type it all. So now how do we get the total revenue? We just add them all up. So let's go total revenue equals revenue class A plus revenue class B plus revenue class C. So what we're going to do here is print out the total revenue, and we'll make it simple so we can add it together easy. So we'll do the total, try to see out, total revenue is total revenue. Now, we're not doing any formatting just yet, so we're going to check. So we're going to do something simple. So we'll do 1, 2, and 1, and somebody can get a calculator. So somebody have what is 30 plus 12, and we'll do 2 of class C, 4, and 38 to see if we got it. So we need to know 30 plus 12 plus 38 to see if this is correct. So I'm going to run the program, and one of you hopefully can get the answer on your phone with the calculator app or Excel or whatever. So let's go with, we're going to do 2, we're going to do 1, and we're going to go 2. So the total revenue is $80, so we need a cosmetic issue, and the total seats sold is 5. So has anybody checked that out yet? So we're going to run the program again with different set of data. So let's do 7, 5, and 12. So it should be 393 and 24 for total seats sold, 12 and 24. So somebody would check 7 times 15 plus 5 times 12, which I know is 60. This should be 105 plus 60, and then 12 times 19. And let me know if it's 393. I'm assuming it is, but we always want to check.
Yep, that is.
All right, so this looks good. So now, so you could be saying, well, why are we doing class A? Why don't we just put 15, 12, and 19? And that is a great answer. Good question. Well, the issue is if you do that, then you have to make sure that you're putting in 15, 12, and 19, or whatever it's 15, 12, and 19. But then what happens if the price changes in there? Then you'd have to go back and change this to whatever you change it in here. And anytime that you use class A price in here, it would obviously be an issue. You'd have to go back in and change it. So let's do something simple. Let's change this now to 20. Class A is the best. And we don't have to do anything else here because now this will automatically be 20. And let's change class B is 12. Let's change this to 15. Notice that if you hold your mouse over on it. Now, I do not know if it does it in Xcode, but I know it does it in Visual Studio. So notice that it automatically does it. We don't have to make one change whatsoever. So let's go and do this. And I'm assuming it's right, so we're not going to check it. But let's just do 1, 1, and 1. So 54 and 3. So this is 12, 35, and 54. So now, here's where we have a dilemma. And again, we're still not printing anything to decimal places. We're going to do that last. Suppose we want to know what the average ticket price was. Well, that's fairly simple. So let's create a double variable for the average ticket price. And we'll do average ticket price or average price, whatever you want to call it. So now we're going to do something simple. So we're going to have a dilemma here. Remember we talked about integer division. So if we get the total sold, the total revenue, what data type is total revenue is a double. So we're good here. And what data type is total sold? That's an integer. So what we're doing here is we're going to divide a double by an integer. But let's just say that had we done this as an integer, so I'm going to change this to an integer. So I'm going to comment this out real quick here. And let's do integer here. Because if you're looking at, well, this is an integer and this is an integer. So let's just do average. Actually, we'll just do av price. And this would be a good way to demonstrate both at the same time. So let's not. So now we have av price. Everything looks good. So let's go and do the average price equals the total revenue divided by tickets sold. Whatever we use, was it total tickets? What do we use? Total sold. And then let's do the same thing with average ticket price. The exact same formula. So you're thinking, well, these have to be the same. So let's go and see if they are. And we'll get rid of this, and we actually need our return. So let's go and see if indeed they are. So we'll just do a bunch of stuff. So we'll do 7, 9, and 22. And we have total revenue, total seats sold is 38. And of course, I did not print it. So let's go and print them. See out average is. This is a good reason why I say do one thing and check it, do one thing and check it, because then you can go back and fix whatever you need to. So now average price. And we'll do end line. And then we'll do the same thing here. See out average is. Only this time we will do av ticket price. All right, let's go. Do you feel lucky? Let's see what happens. So we'll do 9, 7, and 18. So we have, oh, wait a minute. We have the average price is 18, and this is 18.44. You say, oh, you didn't format it to 2 decimal places. Oh, we got to go fix that. So this is very easy to do. So let's go here, and we'll do a simple see out, because it does tell us to do it. See out, fixed, and set precision to. And we only have to do this one time. So it'll stay as set precision 2 unless we change it. So let's go and run this again. And we'll do 9, 7 and 23. I don't remember what we did. Let's see what happens. And it goes, well, wait a minute. It's still 18. And this is because this is it is actually a integer. So we can do if we want to show point, let's try it again and see what happens. So we do whatever, 12, 8, and 17. So now we still have a dilemma. But you see how this is still wrong and this is 18. No matter how you get it, it's still 18 in there. So that's what we can fix this very easily by notice that this is a total revenue is a integer. Let's see. This is what is total revenue? Total revenue is a double. So we're good here, but I think we did the total in here, total revenue as in here. So we have, let's see, we have total revenue and then we have total revenue here. So let's go and change this to, let's see, we want to get the right one, average ticket price, and we have average price. Okay, so we have that different in there. The average price in here, total revenue is total revenue by total size in here, average ticket price. So this happens to be an integer. So that's an issue because even though this is a double, total revenue is a double. Even though this is a double, when it comes back to the average price, it is an integer. So just bear that in mind when you start making up your data types. So we don't really need this right now. And let's run that. And we don't need this here. But I did this to make you aware of whenever you have an integer, as soon as you do it. So let's do one quick example of two different things. So let's go and do a C out. And I'm going to do something that I don't normally do. Let's do 5 divided by 2. So you'd be expecting it to be 2.5. So let's actually do this in the very beginning so we don't have to do anything. And let's go and run this. And I claim it will be, it's 2. So we didn't have an end-L in here. So now let's put an end-L. Let's make this 2.0. So this is now a double. And see how that works. So now what's happening is you're dividing an integer by a double. We just did this. Now you could not do this if this was a variable of, say, like num class A. You could not do that. So so how we fix that, let's just go and let's do num class A, and let's make let's do 5 would be, let's make this 5, 4. I'm looking at what I want to do. So let's just make this 5 here. And we'll do num class A.
I have a question.
Okay, question?
Could we not just use a static cast
Well,
on the answer that
yeah,
we want to be?
that was going to be my next thing. The reason why I said that is you can't do something, let's just say this had to be, we were dividing this by the class A price, something to this effect. Or the so let's just do this, Class A price. So let's just make the number of Class A 50. And then that's exactly what we need to do. Now, I can't put 0.0 here or 0.0 there. So let's see what we get in here. So notice we're back to 2. So that's exactly what you were saying. So let's go and do this. So we're going to type in static cast. And then you need to put in the brackets double. If I could spell double, we would do double. And then you need to put this in parentheses. So that looks good. So that's exactly what it did. Or a lazy way, which is not good, is to do this. So we're not going to do this, but you can do it. I just prefer that you do it this way. So let's see what we get here. And we're still getting 2.5. So that's all you have to do to get that squared away. So that is the whole program. And then what we could do is enhance it and do some other stuff, find out the whatever you want to do. But all we have to do if we want to, let me change this back to 0 and let me pitch this. If the price goes up, we want to change it. Another option you can have is to put this as a float or double and make this 2050. So there's all kinds of things that you can do. Normally prices, ticket price, aren't always even numbers. So a lot of times they're $19.95 or whatever it is. So those are your different options. So when you're doing a program, you want to double check and see all the different things that you need to put into it. That's why an IPO is good for you. Decide the data types, but then you can always change them. So that is it for this video. So hopefully this is helpful, and we'll be doing more.